Hey everybody, we're gonna go over some sample problems for the exam coming up, and I'm gonna be that guy. I know, the one that doesn't give you the exact questions to the test, but the concepts that I feel are probably pretty important. And in this case, we're gonna look over question number 15.434 right now. And so this is kind of basic equilibrium stuff from kind of the beginning of equilibrium. So we have a reaction between PCl3 and Cl2, and it forms PCl5. Okay, and then it's in a 7.5 liter vessel, all this stuff. Okay, so let's set up the problem. Okay, the problem is going to be here. Let's get rid of this here. Okay, so the problem is going to be PCl3 plus Cl2 is in equilibrium with PCl5. And I believe they're all gases. Okay. And the problem says allowed to equilibrate. What is the Kp at this temperature? Okay, so we need to find the P. So let me tell you that one of the basic principles that I believe in, after you get through all the kind of the initial sort of stuff with equilibrium, there are two types of problems. Either find the constant or the conditions. If you have the constant, then you have to find the conditions. If you have the conditions, then you can find the constant. You can't do both in a problem, in a single problem, okay? So when we look back here, it's asking for the constant. So somewhere in this big long list of stuff, we should be given the equilibrium conditions. But so now if we look, it says at equilibrium, the partial pressures of the three gases are these things right here, okay? So now when we go to solve this problem, let's see, ICE, we have the equilibrium pressures to calculate the Kp. So let's see here. The equilibrium pressures, PCl is 1.2 or 0.124 atmospheres. So this is 0.124 atmospheres. And PCl, the pressure of chlorine at equilibrium. How do I know that it's equal? It says right there, equilibrium. So the pressure at equilibrium is 0.157 and 1.30 for the other one. So this is 0.157. This is 1.30. And so this is the information that we need in order to calculate Kp. So remember, P is the pressure of let me make sure that I write this clearly. Okay. It's the pressure of PCl5 over the pressure of PCl3 times the pressure of Cl2. Okay, no coefficients, so we don't have to worry about anything. And so now Kp equals what is the equilibrium pressure of PCl5? So that's 1.30 over 0.124 times the pressure of 1.57. So this now 1.30 divided by 0.124 divided by 0.157. And so Kp equals 66.78. Okay, so that's part A. Okay, this is part A of that, 34. Now it says B, does the equilibrium favor the reactants or products? Okay, so this is question number 34. Now this is a theory question, a chemistry question, not a math question. Remember that Kp is products over reactants. And so for this thing to be a high number or above 1, that number of products is high. So because that's high, that means that that's low. So this is a product favored reaction. Product favored. Okay, so for part B, it's product favored because this is well above 1. Okay, and now our last part here is calculate the Kc for this reaction. Okay, well Kc now, Kc is, so for part C, Kp equals Kc RT delta N. Okay, well, R is the universal gas constant, 0.0821. T is the temperature, and if it's not in Kelvin, in this case it is in Kelvin, but if it's not, we'd have to convert it to that. So that's 450 Kelvin. And then delta N is products minus the reactants, the number of moles of products minus the number of moles of reactants. So I'm going to take this, I'm going to say that, what is the coefficient here? That's 1. Coefficient here is 1 and 1. So the number of reactants is 2. The number of products is 1. So delta N, I'll keep it the same color, that way you can find them. So it's products 1 minus 2, which equals negative 1. Okay? So now we plug it in, we math it. Okay, Kp is 66.78 equals Kc times 0.0821 times 450 raised to the negative 1. Okay, so 0.0821 times 450, okay, raised to the negative 1, to the negative 1, okay, and so now we divide 66.78 divided by the answer, and so now we get a number of, that Kc equals 2467. Now, that's a much bigger value, and so, but that's how concentration is expressed. So there we go. Hopefully that clears up some of the major stuff that has to do with equilibrium, rating equilibrium equations, calculating constants, converting between Kp and Kc. There's a lot of things in this, so this is good. Okay, have a great day.